क्वेश्चन को देखें, यहाँ पर एक स्मॉल डिस्क ए है जो हमारे पास इंक्लाइंड प्लेन पे है, and the inclined plane is making angle alpha with horizontal. Now it is imparted some initial velocity v naught. You have to find how the velocity of this disk depends upon the angle. So look at the trajectory of your particle. Look at the trajectory. If you look at the trajectory, every time your particle is keep on moving, one due to horizontal velocity and other it is coming down due to inclined plane. So generally what we have seen, the wedges from this angle always, but this time is a three-dimensional top problem of inclined plane, how the velocity varies with this theta. And look at the trajectory. Your velocity due to motion along y-axis, your theta due to motion along y-axis will keep on changing. So at any instant you have to find out how this velocity varies. To start it up, look at some initial conditions. Is initial condition, may look at the word v naught. Have a look on v naught. This is actually initial velocity imparted along x-axis. Have the condition there is no velocity that is imparted along x-axis, and initially the angle you use is 90 degree with x-axis. So what actually will happen? What type of motion you will get? Look at the first thing. Whenever the body has motion like v at any instant, this is the instantaneous position of the friction, because friction, you know that, always opposes relative motion. And look at the angle. So if we discuss, see what will happen. So let us first find out what the friction is. If you look at the friction, let's first find out the value of frictional force. You know that in this case we're having the mu, your n is get balanced with the contact force is get balanced with mg cos alpha, as you know it already. If you know the inclined problems, this is the inclined problem, you know that your contact force is always get provided with the inclination mg cos alpha. So as mu is given, if you put the value of mu that is already mentioned as tan alpha, I will use mg cos alpha. So you will get what? mg sin alpha. So let us discuss the motion of this particle now in two-dimensional picture. What compels the particle to come down? Of course, you know that it is mg sin alpha. The opposing force of friction is not F but a component of F, that is F cos theta. Let us find out the equation of the particle first along y-axis. This is mg sin alpha minus the component F cos theta, that will give you m a is not ma, is ma along y. You know that if you want to calculate ay from here, this is g sin alpha minus f by m cos theta. So have a look on this part. This is acceleration along y. But from this equation, let us call it A. If you want to have it g sine alpha and you want to use the value of this f by m, from this equation, you can put the value here as f by m as as g sine alpha cos theta. So we are ready with the acceleration. With this acceleration, your particle is gaining some velocity along y-axis. Now let us discuss what is the acceleration of the same. This time one component of your friction will definitely oppose your velocity v sine theta. It will retard. So let us discuss what the frictional component F, the other one, the frictional component F sine theta will do. You know that F sine theta in this case, F sine theta in this case will give you a retardation along x-axis. Because this is retardation, I will use it like this. So what is acceleration along x-axis? This is f by m sine theta. From the equation A, you can modify it f by m. You can place the word g sine alpha, and you know that there is g sine alpha along with that g sine theta. So as the particle is moving down, you know that your velocities, one along v cos theta and v sine theta, are the two velocities. One velocity along x-axis, one velocity along y-axis. Your v sine theta get opposed with frictional component f sine theta, and your v cos theta get opposed with the frictional component f cos theta. So we can have the acceleration of these as in equation number suppose 2 and in 3. Now come to the main situation. Look at the situation when the particle is some instantaneous position. We are having velocity component along x-axis, we are having velocity component along y-axis. So if you look at the word, your v at any instant is surely vx square and vy square at any instant. Let us differentiate it with respect to time. If you differentiate it with respect to time, you will get it like this. And I don't think so at this level we have to discuss how to do the differentiation. So at any instant, what is going to happen? This is the story. Here 2 get cancelled and your word is v and a. Your vx and a along x, your vy and a along y, place like this. If you can put the value of vx, look at the vx in this equation. Your vx is nothing but v sine theta. If you put the value of vx, that is v sine theta, let us put v sine theta. We're having acceleration along x-axis already. So acceleration along x-axis, what we have already calculated is acceleration along x-axis can also be put like this. The Vy, of course, you know, Vy is nothing but along with Vy, we are having, look at the Vy. This is velocity along y, this is v cos theta, and acceleration along y. So one thing get cancelled out again. This is the v that get cancelled out, and you are getting the net acceleration of the body, the net acceleration as sine theta, acceleration along x, cos theta, and acceleration along y. Again, if you want to have acceleration, let us use the value of this is sine theta. So look at the acceleration along x. I will use the value from the previous equations like minus g sine alpha cos sine theta. Of course, we're having the second word as cos theta. We are having the acceleration along y. What we have calculated already is called g sine alpha. Get the g sine alpha minus g sine alpha cos theta. If we clearly multiply the story, the net acceleration what we are getting is minus g sine alpha. This is sine square theta plus g sine alpha cos theta minus g sine alpha cos square theta. If you can use the trigonometry, this is minus g sine alpha common. The cos square plus sine square will give you the value 1 plus g sine alpha cos theta. So the net acceleration is what? Isn't it g sine alpha, and this is cos theta minus 1. So have a look on this acceleration, what we have calculated at any instant, what the acceleration is. But have a look on one more acceleration. Let us find out one more acceleration. Look at the acceleration along y. Look at the acceleration along y. So what is acceleration along y? This is g sine alpha minus g sine alpha. So if we clearly look acceleration from the previous equation, have you noted that this is nothing but same as that of this one? So a very special thing what you have noticed from here, that the net acceleration of your body and the acceleration along y-axis has the value equal and opposite. Look at equation 4 and 5. This clearly indicate from 4 and 5 that your acceleration is nothing but acceleration along y with equal and opposite. It means the dv by dt of the net velocity and the dvy upon dt of the net velocity along y is having this value. Let us integrate. If you can integrate both sides, if you can integrate, you will get v minus v along y with some integration constant. Suppose if you can find out vy, look at the previous figure. Vy is nothing but v cos theta. So from this word we can use cos theta, but one thing is a problem. So what is the problem? What is this integration constant a? Because we are not using definite integration, we are just using part integration without any limits. So this integration constant can only be obtained from initial condition. So use initial conditions. So if you are aware of initial conditions of this problem, you know that at t is equal to 0, your theta was 90. And also along your velocity along x-axis was v naught. Your velocity along y was 0. So if you can check it, your net velocity, which is the sum of two of the velocity at initial point, your initial velocity is simply v naught again. Let us find out. Let us find out the velocity. Use in 6 to find v naught. So you will get v naught, you will get minus, you will get v cos theta, and you know that from the initial condition we can use theta as what? 90, and this is a. So that will clearly give you the value of a. Once you get the value of a, let us move back to the equation from where I want to have my velocity equation. Use in equation 6. So this is v minus v cos theta, and you know that a is nothing but v naught. If you can put the value v and v cos theta as v naught, you having v, this is 1 plus cos theta. So how your velocity at any instant varies with theta, this is the final answer, that with which the velocities keep on changing. So have a clear look on the problem once again. So you have launched the particle horizontally along x-axis. Afterwards, due to mg sine alpha, it start bending down, accelerating down, and the friction in this case does the two cases simultaneously. It retards your velocity along x-axis, and one component of friction retard your motion along y-axis. And along with the trajectory, the theta is keep on changing. So how to find out theta, what to find out, how to tackle with the problem. So I hope so you will get the story. Thank you.